Hi, my name is Steve Sharman. As Jeff has mentioned, I'm one of the TSAs within the worldwide DC team, and I'm here today to demonstrate to you how we can use our day 2 operations tools to help change the way that customers troubleshoot their network. And what I mean by that is we want to move them from a reactive mode of network troubleshooting to a more proactive mode of network troubleshooting. To demonstrate this to you, I'm going to take you over to one of my favourite companies, Mangoes. And over at Mangoes, we'll learn how the developers there and the network team are now changed the way they work and work much more closely together. So firstly, there's two key characters that I need to introduce you to. There's Dave. Dave's one of the developers, and there's Amy. Amy's the network admin. And historically, there's always been a bit of friction between Dave and Amy. And that's because Dave's always felt that Amy can't deliver things as quickly as he wants them. So he wants to have security rules changed whenever he wants them. He wants to have new port groups available to him whenever he wants them. Whereas Amy's always been more concerned about the network infrastructure and the wider impact of any changes. And she certainly wouldn't let Dave log on to any controllers and start configuring things, because let's face it, he's bound to do the wrong thing. He's bound to just put a very open permit any rule on the network. But all that's changed with the new network that they've got in place and the new way that they can actually do things within their infrastructure. And Amy set down some ground rules, and she said what we'll have is we'll have two logically air-gapped tenants on the network. We'll have a development tenant and we'll have a production tenant. And in the development tenant, that's where apps are kind of obviously developed. Those applications can be developed in a very open way, so they don't have to lock down the ports. They're not too concerned about security because it's air-gapped. There's no connection from the outside and there's no connection to the production network. However, when apps move into production, it needs to be much stricter. So we need to now only have secure ports open. So for example, SSH or SSL. It needs connection to the outside world. So we have to have that configured. But what we absolutely don't want is any connection to the development network where stuff is much more open. It needs to be ring fenced in a secure environment on the physical infrastructure. So how would this actually look? So Amy's put forward this, I guess, approved development state that they can have within the network infrastructure. So over in development, we've got a couple of port groups that we're going to use for our application. So we've got a web front end and a database at the back end. And as I mentioned before, there's quite lax security rules there. It's development, we want things to be quite open and fluid to help them develop these applications very quickly. However, over in the production network, things have to be different. So we need to really lock down the ports that we're using because we're going to expose our services to the outside world. And all of this exposing of services, all of the rules that get put in place, well, Amy's been quite happy to let Dave do this now. So through the API, he's actually able to push these rules into the network and do his own network configuration, albeit within a ring-fenced area. But obviously, Amy's got some concerns. And her concerns are, how does she know that what Dave is doing is actually correct? How does she know that the rules that he's put in place that allows the services to be exposed to the outside world are actually secure? How does she know that you can't connect from the production network back into the development network? Well, to help you understand this, Amy's leveraging our day 2 network operations suite of tools to really help her prove what is working or not on the network. So the first thing that she wants to do is to be able to assure the intent. So she's going to set some ground rules and actually look at the rules that are put in place on the network. And so then take those rules and say, for example, we can't have anything from development talking to production. That's just not allowed. We need to have a rule that says you're only allowed to use secure ports when you're connecting in from the outside world into the production network. Secondly, she wants to be able to guarantee reliability. So she needs to really know about problems before somebody picks up the phone and says there's a fault with the network. So she wants to be much more proactive about the way that she's going about her troubleshooting. And finally, in talking about troubleshooting, she needs to be more intelligent. She needs to have access to data when she wants it. So she needs to be able to look back in time and say, well, what happened on the network within the last hour? Or what happened? What was the result of those network changes? So what we'll do now is we'll actually drive over to the demo and actually delve into it and see exactly how this is going to work.
Okay, so let's have a quick look at the network over at Mangoes and see how Amy's got things configured. First thing to note is there are a couple of tenants on the network. We've got a production and a development tenant. And in development, we've got 3 app profiles for our blogs, our database, and our load generators. And in the production tenant, we've just got our blogs and our database, and we've got a contract that goes to the outside world that is allowing TCP on port 443, so that's our compliant access. We've also got a couple of service engines. This first one is running one of our day2ops tools, the network assurance engine. And if we jump over to the NAE, what we're able to see at the top is a timeline of what's happened, what events have been gathered from the network, and we can go forward and backward in time to actually analyze what's happened. And it will show us all the different events that we've got, and if we search for compliance at this time point, we don't have any specific errors that have been identified. But as we scroll forward in time, we're able to see, has anything happened on the network that's caused us to go out of compliancy. And as we can see here now that we've got more smart events that have been flagged, and if I search now, I've got a segmentation violation and a traffic restriction violation. The way this is created is that we make some object selectors that define things that we're interested in. We've also got some traffic selectors, so protocols that we're interested in, and then we create some requirements, so the air gap and the secure access, and finally we bundle these up into a compliance set. And we can see here that we're down to 28% compliant, and we're able to drill in and actually have a look now at what's happened on the network, what changes were done to cause it to go out of compliance. So firstly, from a segmentation perspective, we can see when this was first raised and when it was cleared, and we can look down further and we see that we've got a contract has been added from our production network to our development, and that's allowed port 1433 access from the web tier to the database over there in dev. Then we've got a traffic restriction violation as well. Again, we can drill into this, and we can see here that we've got port 80 added to the contract from the outside world. Again, this is insecure and therefore out of compliance. What we're now able to do is look back in time and actually see when this happened and who made these changes. So the first thing we'll look at is our outside world, and we can see port 80 has been added. And if we drill into this and look at the changes, we're able to see here that Dave has made those changes. So the developer's gone in and added some rules that he shouldn't have added. And then we're able to look into our compliance between the tenants, and we can see that again, Dave has added a contract that allows our production network to talk to our development network on port 1433. We can then use our other services engine that we've got here to look at network insight resources, and NIR is going to allow me to look at the different resources, so the switches, etc. on the network, but specifically here we're interested in the flows that have happened during that time period. So at the top of the screen here we're selecting the last 6 hours from a time period perspective, and then we're able to do some searches, and we're able to say, for example, destination address of my web server tier. So this is the IP address of my web server in the production tier, with a destination port of port 80. So has anyone accessed my server using port 80? And as we scroll down here, I'm able to see that yes, so certainly at this time point we've got IP address externally of 192.168.10.12 has accessed my web server on port 80, and this was actually showing now that traffic has hit the web server when these changes were made. The next thing that we can look at is, did any traffic get transferred between our source IP address of our web server in the production network and the database server that sits over in our development network? So we exposed it, but did anything actually happen? So if we search on this, again, the source and destination IP addresses with the same time period, here we can see that there's been actually no access. So nobody has accessed our development database from our production web servers. So these different tools that we've got from the day2ops really allow us to drill in and see when changes were done. So who made the changes, when were these changes done? And also now we can actually see, was any data transferred across the network? So it gives us the ability to not only look at the changes, but look at the impact of those changes and actually analyze down to the different source and destination addresses that are learnt on the network and say, was any data transferred, even though it was out of the compliance, did that cause an issue? In the first example, that did cause an issue. We could clearly see that data was being transferred from an external IP address to our web tier on port 80 that shouldn't have been allowed. But when the database was exposed from the development network to the production network, again, I could actually prove now that no data was transferred. So even though it was open, it wasn't actually compromised. So there was no issue with our database. So hopefully you can see these day2 operations tools that Amy's invested in really allows her to drill in and actually see who made changes, when those changes were made, and what was the impact of those changes. This is the end of the demonstration. Thank you very much.